You didn't take attendance last week class? Okay, last class was already, right? Holiday? Okay, 23. Oh, this is 22. We have one more week. All right, let's start. What is time series? I cannot use the computer because of unknown reasons so far. We'll try one more time. Ta-da! Work. Alright, same time. I think it's the camera. Right? Doesn't want, it's very shy. The camera is on, it wants to work. Okay, we'll go quick to the slides. Now, okay, let me explain the time series first. Simply, time series are basically for forecasting purposes. Forecasting models. Okay? We want to forecast the next level, next time, next period. For example, you have sales, right, in different months. So you can write here the months. First month, time low, time high, time bad, right? So we have first month, suppose you sold 10. Second month you sold 9, third month you sold, say, 11. So basically, of course, it's very small sample size, but imagine you have like this, maybe 100 months, okay? Using this data, we will try to figure out some movements, some patterns. If we can catch those patterns, we can estimate, we can predict, we can forecast the next period's sales, for example. Okay? So the idea is, the main purpose is forecasting the value in the next period. The period might be year, period might be month, might be week, or might be next 10 years. Okay? It's all depending on your data. Now I will turn on the slides because lots of things are non-mathematical here first. Last one. So you might have seen, right, in newspapers or in internet, things like this. Like stock market, right, for example. So the stock market movements are a very good example to apply time series. Because stock market movements, for example, this is stock of Facebook. Right? They will start to open for the market, I think tomorrow or next Monday, I don't know. Anyway, suppose Facebook's stock levels are like this. And I want to buy Facebook stocks. Okay? I will have like $10,000 and I want to buy 1,000 shares, each $10. What should I do? If the stocks are going this way, right, or this way, or whatever the way it goes, can I estimate what will happen to Facebook stocks next month, or next day, or next week, depending on my plans? So the problem with the stock market movements, they are random walk. We call them random walk. And random walk is basically, there is no pattern. That's why it's random, right? It's no pattern in the random walk. So it's much harder to estimate random walks in a way of time series or in a way that we will learn in this class. But we will learn some more simplistic model that will help us to understand mostly the data series which are cyclical. For example, if you are selling raincoats, right? Raincoats in Vietnam, your sales will go up around these months, right? Because rain starts around May, June. And then your sales will go down every year about November, right? December, because rains will stop. Does it make sense? So there is a cyclical movement. Sales go up, sales go down, right? You can advertise every year for your raincoat and you can increase your sales. So this is your sales in January 2011. This is your sales for January, June in 2011, June in 2012, June in 2013. But every year in November, your sales are down because no rain, right? People don't buy raincoats anymore. But there is a trend. Your sales are constantly increasing because you advertise, because you have more customers, because you have more employees, because you are more widely known by the people in Vietnam, right? So there is a kind of year by year increase. So you can see it now, what we call them one by one. That's what time series is. So we have basically 4 components of any time series, except for random walk, okay? First of all, trend. Trend is this line, basically. The long-term change, long-term direction in the movement, in the time series data. It can be up like this or down like this, right? Depending on your data, okay? So trend is the first one, the long-run general direction of a business climate over a period of several years, or you can go many years, like 20 years, 30 years. For example, you can look at the unemployment rate, inflation rate, things like that you can check by the trend. They have more like inclined to going down or going up for several years, right? The economy is good, unemployment is going down for many years in the past. If the economy is bad, unemployment is increasing every year, right? So basically you can estimate. Then we have cycles and seasonal effects. These are the same things actually. The only difference is the time. Cycles are these patterns, a bit bigger than that, because they are more than 1 year. You can see here patterns of highs and lows through the data move over time periods, usually of more than 1 year. Okay? Things like this, economic recessions, right? Right now we are getting more and more often recessions in the world. If you look at the right, we had 1997, Asia, right? And then 2008, another big one hit the world. So it's getting more and more often because the world is much, much global, right? If something happened in China, it's affected, right? It affects the USA, or something happens in USA, the whole world goes down. It's very much connected. So basically, cycles are mostly things which happen, the ups and downs, more than 1 year time. And seasonal effects, the same thing, but less than 1 year. So if you think, right, this is, for example, if this is your cycles, your seasonal effect will be inside, okay? Ups and downs, shorter terms. Like, for example, as I said, right, every summer you can sell more air conditioner, right? Every winter you can sell more heater, for example. During the World Cup times, you can sell more televisions. Because people want to watch, right, World Cup matches with the big screen, LCD, blah, blah, blah. So they want to buy TV or internet, whatever, right? So, for example, then I say World Cup, right? The effect of World Cup will be which one? Cycle or seasonal effect? World Cup. How often do you have World Cup? More than 1 year. Which one is cycle, right? The sales of televisions will be affected by the World Cup every 4 years, once in 4 years. It will be cycle. But think about the question of raincoat. The sales of raincoat, right, will go up every year in rainy season, right? So it will be seasonal effect. It will go down in summer or winter in your case, okay? In Vietnam case, I mean, different countries have different. And then we have irregular fluctuations, which is not explained by anything at all. Now, as I said, right, the world is now very much connected. That means what? You remember the famous movie, Butterfly Effect? Have you seen the movie? Butterfly Effect? No? You only watch Harry Potter, right? Okay, the butterfly effect means basically if a butterfly swing its wings, it might cause a tornado in USA. Sorry, a butterfly in China swings its wings, it might cause a tornado in USA, it says. That's the, of course, exaggeration, right? Quite a big picture. But the idea is this. We are so much connected to each other that a small thing happens in somewhere, right? In USA, in Colombia, in Bolivia, in Brazil, anywhere, might affect anywhere else in the world. Vietnam, China, Japan. So now what does it mean? It means we can never control our environment. Right? There is no way I can say the price of water will be tomorrow $11 per gallon or whatever, or price of petrol. Because there are so many effects, so many things affecting price of oil, right? Politicians, their wives, their private lives, everything affects everything. You see what happened to the French guy, the IMF head, right? He was in prison and it made a huge thing in French economy because he's the head of IMF. Can you imagine, I mean, the whole thing going on and then he's in prison? So that's we call irregular. We can never know the future. We can never know what affects what exactly. Right? There are millions of things affecting millions of things. There is no way we can estimate their influence on each other. Impossible. So irregular, they are like this, like in stock market. But they are small. But if they are big effect, right, I will see them. Like World Cup, right? I can see what's going on with the World Cup. So I can see it's big thing. But if it's something small, in stock market movement, right, I can only show them this way. Small fluctuations, small movements. Okay? So we call them irregular or unexplained variation, same as in regression. Okay? Things happen without our reasoning, beyond our reasoning. We cannot know why they happen. Why the data go up here, why it went down. And you can guess. But is it true? We can never know. Okay? Basically. And last one, stationary, it's basically the data is not moving. It does not move up or down, it stays same. This is actually a very important concept, but we will not go much in detail about this concept, but it's a little bit kind of deep inside. Now look at the next picture. This is what I said, right? Trend. Next one is cyclical or cyclical, you can say. Seasonal and irregular. And all together you can see in this picture. Here. Okay? So the big line is a trend. The green line is a cyclical movement. Blue is blue or purple? So now the red one is seasonal Okay, smaller, and then the purple one or blue one is irregular fluctuations. Now, before we go to next level, the math part, I want you to look at the questions in the page 100, page 100 minus 14, meaning page 86. I said 100 first, but it's not 100. Page 86, question 1. I'll walk around and see what you are doing. I can keep the definitions here. Except for the last one, you can answer all. And I didn't mention it, but error. Okay, error is same as error we have done before. It's basically the same. Forecast minus real value. It's similar to regression, right? When you subtract the observed value from the forecast value, you get the error. It is exactly the same as what we have done in regression. Prediction minus observation, right? Same. Okay, answer question 1, please. Quickly, just fill the blanks. My voice is there, right? Over there. But when I move? Come on, quick. Look at the picture to get the whole idea. Except for the last one. We have maybe even you can do the last one as well. Cyclical effect and cycle, same thing. Cyclical effect and I think cycle, they are the same thing. You can use the words one for each other. Cycle and cyclical effect. So, let's finish, right? Finished? Okay. What's the answer for the first one? The long run general direction is trend. The patterns of highs and lows through which data move over time period, usually more than 1 year, are cycles or cyclical effect. Both of them are same. Patterns of data behavior, blah 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 blah, by month, measured by month. Seasonal effects. And then next one, rise and fall of time series data over periods longer than 1 year. Cycles or cyclical effect, again, one of them if you haven't used the other one. Unexplained fluctuations, irregular, and difference between the actual value and the forecast. We call this thing, right? Error for the individual forecast. You're given EI, I here, right? Which term? I here the time. So time I, error for time I, which is basically then equal to what? Forecast of time I and the real value, actual value of time I. Now, what do you want? Okay, let's finish this part now. So what we want? We want this number as minimum as possible, right? You don't want huge error. Because the small error means you are successful, right? Your forecasting is work. If the error is large means your forecast, right, model does not function properly. It's giving huge errors. What's the point? So that means I will try to minimize the error. But how can I measure it first? Measuring error, we have two important measures or two important way of doing it. One is MAD, the other one is MSE. So this is what we call error, right? You can see here. Error is at the time t is the actual value minus your forecast. So suppose in January, right, actual value was 100, but you forecast last month, your forecast was 95. Your forecast, you think that it will be 95, but at the end of January you found that it is 100. So the error is how much?
Minus 5.
Xt minus Fy minus
No, minus 5.
Xt minus Ft. Ft does not really matter which one. 5. Okay, you can take absolute value. It's always positive. Okay. It doesn't matter which one you write first, because we will never use the actual value here. We will only use the absolute value. Okay. Because it doesn't matter, right? How. It doesn't matter you are below or above. It matters how far. The distance between these two numbers is important. Doesn't matter it's above or below. So then absolute value is what? 5. So using this number I can calculate MAD. MAD is mean absolute deviation. Right? You can see here. So basically it is the mean of all absolute values, sigma, absolute value of errors divided by number of errors. Okay? So you add them up, all the absolute values, and then divide by, be careful, not the number of forecasts of number of observation, you divide by number of errors. Be careful, sometimes they are not the same. Your errors sometimes one level or two levels less than number of observations because you don't have data yet for next month, right? So you might have less information. So be careful here. This is number of errors, not number of observation or number of forecasts, right? Don't pay attention to here. Listen to me. Listen to the wise man. Wise man speak, alright? Next is another measure similar to MAD, is called MSE, mean square error. Same thing, but this time we take square of each error and then divide by n again. It's the same issue. But then what we do here, right? Take square, make them positive again. The same way, right? Add them up and divide by number of errors, okay, that you have, you calculate. Now I want you to do the question 2. Question 2 is, it gave you, right, if you look at, we have the actual rate of interest and the forecast value of interest. What you have to do is calculate the error in absolute value, and then error squares, and then find MAD and MSE. Use a calculator, please. Come on, come on. Any question? Any question?
Yeah.
Wise man here, don't ask him, he doesn't know anything. Take the absolute value, don't worry about minus values because it doesn't mean anything to us. You sure about the 0.0003? I think it's 0.036. I think 1 digit extra here. Listen to the wise man. But I might be wrong. Never trust wise men as well. Don't write the numbers down, just calculate directly. Subtract them and then write here. That's what you add them up and divide by n. So you get n and n. I can show you the answers on our solution sheet. Oh, that's right. You're in level. Here's the answer. The numbers that you will fill the table. Errors and error squares. If you add them up and divide by 12, because we have 12 errors and 12 error squares, MAD is 0.055 and MSE is 0.065. How do we use it? By itself, neither MAD nor MSE can make sense. But suppose I have two different models, right? Model 1, if MAD is equal to 4. Model 2, forecasting model, right, is giving MAD is equal to 2. Which one is better? Which model I should choose? I should choose second model, right? Because it gives less error. It's more trustworthy, it's more reliable. It gives, on average, right, the error level is lower in model 2. So basically, both MAD and MSE can only be used when you want to compare them with another MAD and MSE. Okay? So you can see the best model in many models. You will see if you study quantitative analysis next term, some of you might study, you will create a model, right? And each model you will calculate MAD and MSE and you will eliminate some of them to get the best model for the chocolate sales. If the projects stay the same, it's about chocolates. So basically the idea is to create minimum error model. Continue. So not here. Right. Now I will talk about some very simple, very primitive level of forecasting models. We start with naive model. As the word in French, naive, it doubles up. What does naive mean? Naive means mustn't. No, something mustn't. Naive might mean optimist. Optimist, like always think about the good things. Tomorrow will be so nice. Everything will be beautiful. I will have a nice life. No one will suffer, this kind of thing, naive thinking, right? So optimistic thinking. So naive model is very simple. It basically, it basically relies on a very simple concept. It says that forecast of next term, t plus 1, right, is equal to observed value of this term. That's it. So what happened now will happen tomorrow. What happened this week will happen next week. What is the value for this month's inflation? Will happen same next month's inflation. What is the interest rate by the central bank in 2012? I think it will be same in 2013. Okay, that's it. Naive model is basically just taking the value from previous term, or this term for the future term. Okay, make sense? Does it make sense? No, it doesn't. How can it make sense? How can you say tomorrow will be same as today? It doesn't make sense. It doesn't matter if it makes sense or not. The problem here is we have a belief. We have an assumption. Assumption does not make sense, no problem. But we believe on it, so it's fine. That's it. So, the forecast of tomorrow will be observation of today. Now, in real life, we never use it directly. But we use this concept as an initial point for larger models. Just for the first step. For the first step, I use, and then I never look at it again. I use different models building on this. So, this idea can be a good start point only, but nothing more than that. Because if you apply right, then what's the point of mathematics? Today temperature is 30 degrees, tomorrow will be 30 degrees again. It won't work. Tomorrow can be anything. Can be even snow tomorrow in Vietnam. You don't know. It won't snow, no? Ever snow here? No? In your dreams? No? Anyone here dream of snow in Vietnam? In your head? You have some imagination. Thank you. Come on, you must have some good dreams, right? Snow in Vietnam, snowman on the Big One Main Road, RMIT has a snowball. You're playing snowballs with each other. When I went to Turkey with my wife is also from here, Vietnam, Thailand. So she has never seen a snow in her life, right? She thinks that snow might hurt her head. But snow comes from top, right? They might hurt when they touch. I said, no, it's not something hard. Hard to explain. Okay. I will continue now, something more complex. Moving average. So I will use it. Later you will see how we, no need to talk about it too much now. Moving average. Moving average is basically, as the name suggests, right? An average which is moving. How can average moves? Think of this. I want to estimate the forecast to time t plus 1. I will go back n years back. N years. And take the values from x, right? T, x, t minus 1, xt minus 2. If you make ft, then it will be easier. Until where? Xt minus n. So I will take the average of last n terms. Now be careful. Why we call it moving? We call it moving because if I want to calculate ft plus 1, ft plus 1 will be what? I will start from xt, right? Because t plus 1 minus 1 is t. So I will start from xt plus xt minus 1 plus until xt minus n plus 1. It's one term, right? Forward. Divide by n again. Okay? So for example, if I have months, January, February, March, April, 9, 10, 12. These are the observed values. Actually, I want to forecast FI 3 months moving average. 3 months moving average means what? I have to go back 3 months, right? In months. So, I will estimate April only. I cannot estimate January, February. I don't have value for them. 3 months, I can't go back. So, there is no value here. Right? Because I cannot know the value of March because I need December. Right? Here for 3 months. So I just skip them. I start from April. April will be what? 9 plus 10 plus 12 over 3. Right? 10.33. So that's basically the moving average for April. Suppose I know April value come up 11. Now tell me what is the forecast for May? Now I will add, right, these 3 months. 10 point something. 10 plus 12 plus 11 over 3. That will be equal to 11. Okay? So you are moving. When you calculate the forecast for April, you take the actual values from January, February and March. Previous 3 months. When I calculate the forecast for May, I take the previous 3 months. What are they? April, March, February. I forget about January. It's too far, right? It's too much past. I don't care anymore. In my model, I only take 3 months. If you go to internet, the website I gave you for assignment 1, assignment 2, there are options there. You can click, you can have 6 months moving average of stock prices for 3 months. They give you all the averages with the graph as well. You can decide whether to invest or not invest in that stock because these are very commonly used by investors. 3 month average, 6 months average, 1 year average, because they are very kind of reliable source of information for brokers, for investors. So, make sense? Okay, I won't ask to make sense. Do you understand? Won't make sense anyway. Again, the whole idea of what we are doing here is all estimation. It has no scientific value behind. We just believe that the whole thing, even the ones we will learn later, whole thing is based on the idea of we can find patterns in the past data and we can apply the pattern in the past to the future. But the whole idea, the pattern in the past will happen the same in the future is not scientific, right? Can you say that as a scientist? What happened in the past will happen in the future? Can you? No, we can't. We only trust. In 95%, 99% it works. Because we are all humans. Nature is same, right? Our behavior is almost the same. the way we behave, the way we buy, the way we sell, the way we, escape from the fire, the way we don't want to die, all the same. So we don't change every day. Therefore, the data does not move a lot. Okay? The movements are slight and in the long term. So we can trust these things because human nature does not change very quickly. Okay? So that's why we can, like sales data, people always eat chocolate. I mean, how can you imagine that people will stop eating chocolate one day, like cut the whole thing, no chocolate anymore? No, right? People will keep eating chocolate. So you can trust what happened in the chocolate sales in 2011, same in 2012, unless something happened, very bad, like chocolate got poison, or some people died of eating chocolate, or milk. Even for that thing, we have models. Even for like very, very contingent situations like that, for example, milk get poisoned. Then you can put in your regression analysis some dummy variables. Like for 1 year, you had poisoned milk, and the sales go down. So what happens? You can analyze this as well. I want you to work on question 3, 4, and 5. Question 3, 4, 5. First one is naive forecast. Quite simple. Why not? Are you waiting? What's the naive forecast? Basically, beginning of 2009. Will be December 2008, right? So previous period. So naive model. For the naive model, you will just take the previous period. If you are looking for January 2009, it will be equal to what? Actual value in December 2008. That's you have in your data set, right? The actual value of 2008 December. What's that? X. Actual value. 1.97. Look at the actual value of December 2008. That will be, if you look at your data set, 1.97. Did you do this thing now by yourself? No, not you, right? Question you can also see on the screen. That's the answer for question 3. Naive model, right? Forecast of time t is equal to previous time. You can write this way as well, fine, doesn't matter, okay? T plus 1t or 3t minus 1, same thing. As long as there's only one difference, right? No problem. Okay? So f January 2009 is equal to x December 2008, 1 year before. So it will be 1 month before. So what about next question? Using the actual rates by the help of 6-month moving average. Now 6-month moving average means what? You will go back 6 months, right? In the actual values to calculate the forecast for January in 2009. So which months are I will take? which months I will need to calculate the forecast of January 2009? December, November, October, September, August, July. 6 months. I don't need June. Right? 6 months back. So, if you get back 6 months in time, you will get 1 point. Interestingly, same value, right? You get the naive forecast, and this same. How amazing, right? It's just coincidence. Good luck. Okay, next one then, question 5. Suppose that the interest rate in January 2009 happened to be 2.02. Your forecast is not, anyway, but it becomes 2.02. Again, by the help of 6-month moving average, calculate or forecast the interest rate in February 2009. Now, if I want to calculate the forecast for February 2009, I will go again 6 months, right? 6 months from February will be January, December, November, October, September, August. Do I need July? No. But real values, and I will use this one, right, for January. Actual values 2.02, not the forecast. This was my forecast. It's quite wrong, actually, if you see. Right? So, do it this way. From January 2009, go back until August 2008 for 6 months. Divide by 6, 1.965. Okay? Any problem so far? Any question? Any answer? What's the meaning of life? Why are you laughing? Ask me a serious question. What's the meaning of life? Huh? To laugh, right? To be happy. I think the best answer to that question, what's the meaning of life? To keep quiet. Nothing. Absorb the question, swallow it, and do nothing back. So what's next? Okay, basic. Alright, now we have done 2 models, right? Naive model and moving average. Now we can elaborate this one a bit more. We call weighted moving average. Weighted moving average. It basically means that, now what I did here, look. When I calculate this forecast, are you writing? All right. When I calculate this forecast, I assume what? Each value in the past, right, has equal amount of contribution to the forecast. I said that, look at here, what are the coefficients here? 1, right? All of them are 1. So I assume that, for example, n years or n terms back, actual values contribution, right, power, is same as last term's contribution. But is it that way in real world? Don't you think we must think that the closer the time, right, we must think it has more effect? Do you think? Don't you think? You don't think? Okay, I think. We think. Assume, right, that I think that, for example, the most recent months are more important. Most recent months are more value to calculate the forecast. So I might give, for example, different weights, right? I give W1 weight, this one. I give W2, W3, Wn. And I also here will what? W1 plus W2 plus until Wn, because this n is equal to what? Right? I add all these ones up, I get n. Now I can't have 1, 1, 1, I get different numbers here. I will add them up. So the result becomes something like this. Forecast of t plus 1 will be equal to what? You can write as W1 times, okay, let's use again t same. W1 times xt minus 1, or you can write t minus 1 if you want. Wt minus 2 times xt minus 2 plus until Wt minus n times x t minus n. Divide by, huh? Something wrong? Okay? And you can write this thing as what? In sigma notation better, I think. Sigma Wt minus I times the xt minus I from 1 to n divided by W I from 1 to n Wt minus I. I mean, the formula might look a bit complicated, but it's so simple. Just multiply by the weight and then divide by total weight. Okay, there are some examples here you can see. Moving average. Example of moving average. Error of moving average. Okay, why am I doing this one? This is the example, right? Look at the example. Suppose a 3-month weighted average is computed by weighting last month's value by 3, previous month by 2, and the month before that by 1. Means what? I will multiply the previous month by 3, and month before that multiply by 2, and the month before that multiply by 1. Divide by 3 plus 2 plus 1. 6. Okay, a perfect number, right? So it's the weighted average basically. So you will get this is the forecast for time t. It's t minus 1 here. So let's imagine a question. Suppose I do 3-month weighted moving average, WMA. Okay? And I use same principle, suppose. Okay? What will I do again? Tell me the operation. I will multiply what numbers? If I want to calculate April by the same principle, the 3 months moving average, by giving 3 weight for the previous month, 2 weight for the month before that, and 1 weight for the 3 months earlier than that. April. So what should I write? Tell me. 12 times 3, right? Will I give 3 weight to the previous month? Plus 10 times 2 plus 9 times 1. Divide by 10.83. Alright? Now what about May? Tell me the operation for May. Don't speak. Rest. Tell me the operation. 11 times. Plus, come on, speak up. 12 times what? 5? Who said 5? I said. 10 times? 1. Divide by what? 12? 6. 30 to 27. 57. 67 over 6 will be 11.16, right? 1666. Okay? Understand, right? How it works. So here I use this method, the one in the question, but it might be different. Okay? Like in your question, see your question 6. Welcome, question 6. Done? What's the answer? 1.91. 913. Okay, it's also 321, right? What about question 7 then? What would you say? Errors, comparing the errors from question 4 and question 6. What is the error from question 4? If the January real value is 2.02, right? Given. Your forecast was what? 1.97, right? And then in question 6 it's 1.913. Which one is better? Question 4 or question 6 is better? Question 4 is better, right? 1.97 is closer to 2.02. This is far. So I can use them, right? This model. But again, you can't decide only for one error, right? Because we look at all errors and find the average. But assuming we only have one error, right? If I based on the error, I will say the model we use in question 4 is better than the model we use in question 6, which gives less error. Okay? Okay, we almost finished the topic. One more thing left. Maybe the hardest one so far. These are all algebraic. We have now something exponential. And we also will use here the naive model. Exponential smoothing. Exponential smoothing is basically basically we are relying on some numbers, some alpha values. Let's see on the slide. Shh, don't use the homework in my class. What are you doing? Give it to me. Not even a mobile, it's iPod. It's even worse. Right? It can play music. So it's basically forecast of time of t plus 1 is equal to alpha times xt plus 1 minus alpha times ft. Now you might ask, teacher, you won't ask, but I will ask you to ask me, why do we call it exponential? Say it. Ask me. Teacher, why do we call it exponential? Why do we call it exponential? Good question. It's called exponential because, look, here, right? Nothing is exponential, but this thing is a recurring relation. If you look at the function, look, f of t plus 1 is taking value from f of t. This is the first time we have such a thing, right? We have, I want to calculate the next term forecast, but I use, again, the forecast of this term. Normally I only use what? Real value, right? Actual value. But this time, I also put my forecast in the equation. That's very weird. Not weird, but it's interesting. Right? So basically, this brings me to the explanation. Now imagine, what's ft plus 2? Alpha times xt plus 1 plus 1 minus alpha. What's ft? ft plus 1, right? ft plus 1 is this. Put it back. Alpha times xt plus 1 minus alpha times ft. And if you multiply, what will you get? You see? You got the exponent. And it's only one level down. Imagine you go back 10 terms. The number become 1 power 10. It becomes exponential function. So you can define ft plus 2 by ft, 2 terms. Right? You can do 3 terms, 4 terms, 5 terms, no problem. But of course, the equation will be much more complex. Because the more you open, right, the more terms you will add. That's why we will use Excel or computers basically to do this kind of things. Right? So, it's quite simple. Alpha is called a forecast constant, right? Exponential constant, exponential smoothing constant. This is one word. Exponential, okay? Not exponentially. I should be here. Okay. So alpha is a number between 0 and 1. Alright? Now, what is the meaning of alpha? It's very important as well. Look. If alpha is, suppose, 0.8. This is what? 0.2. That means what? That means I give more value to actual value, actual number, compared to what I give to forecast. Right? So it means I trust 4 times more than I trust the forecast. For me, actual value is 4 times more important than the forecast of my previous term. But you can do the other way around, fine. Whichever works better, right? There is no rule. All based on your errors. You try both of them, you check the results. Which one gives less error, less MAD, less MSE? Whichever works better, use that one. There is no certain rules for alpha. It's all up to you. Normally, analysts are doing alpha value like from 0.01 to 0.99. 100 different values. And look at each error terms one by one. It will be done in a few seconds by computer, right? Not a big deal. So computer can do it very quickly to find the best alpha value, which can give the minimum MAD, minimum MSE. And use alpha for the forecast. Okay? In your case, we will give you alpha, you will use it. Right? Or we will give you 2 alpha, you will use 2 alpha and then compare the results. Okay? Simple. So, how do we do it? Look, it's quite simple. Suppose again I have January, February, March, April. I have numbers. What were the numbers? Same numbers, 9, 10. I used the previous question there. 9, 10, 12. Now, suppose exponential smoothing, alpha is 0.2. Okay? Alright. Can I estimate this one? No. I don't have any value for this, right? Can I estimate this one? I don't have a forecast here. I can't. But as I said, right, naive model, the first model we have done, right, cannot be used by itself, but can be used in other models as an initial point. So now, I will use naive model for the forecast of February. That means what? I will take the forecast of February from actual value of January, right? I will take the number 9. Okay? Naive approach. I think a model is called approach, you can get a better word. Because it's not a model. It's just a one step. Okay? I take the first forecast by exact value of actual value of previous term. Okay? And then now I can apply exponential smoothing because I have both actual value and forecast for same term, February. If I want to estimate March, I will do what? Alpha times 0.2 times actual value plus 1 minus alpha times forecast of the previous term, right? Both same. So 0.2 times 10 plus 1 minus alpha is 0.8 times 9. Okay? You must calculate this before you continue to this. Because you need this number for this. Right? Because recurring function. The function, be careful here, right? F of t plus 1 is depending on f of t. So you need the forecast of previous time to forecast the next one. So, okay, what's the answer here? 7.2 plus 2, 9.2. Now use this number. What will I have? Tell me the operator. 0.2 times 12 plus 0.8 times 9.2. Okay? And the answer is telling us 9.76. My suggestion to you is basically keep, because exponential, right? The digits will keep increasing here. Keep them at 1 digit. Keep it simple. 9.8. Otherwise, it will keep increasing. Every time you will have 1 more digit extra. It's not Very important. So just keep it simple. Okay, can you calculate May? April after April, May, right? Suppose May is 10. Calculate May. So almost finish the time. But I want to finish all the chapters so we can continue next class. Exactly 10 with 9 points.
10.0.
Okay. So what's the operation? 0.2 times 11 plus 0.8 times 9.8. Okay? The answer is, they say 10. It's very close to the real actual value, right? Just me. So that is the end of the class. So your homework is to finish all the questions. We page 87 as well. 87. So all questions here we have done. Also, you can do the questions. Okay, I did more homework because page 89. Question 1, not 2, 3, 4, 5, 6, 7, 8.
Dễ, nó không phải dễ.
89 and 90 and finish 87. Okay. 87, all questions you can do now. So you can go to model. 89, 90 is the quiz paper. Some we haven't done yet, like the linear model and second degree model. But you can do 1, 3, 4, 5, 6, 7, 8.